Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P086D, indicates a fault with the neutral position sensor A circuit, identifying it as having a high voltage output. This specific DTC arises when the Powertrain Control Module, PCM, detects an abnormal voltage level from the neutral position sensor, which is necessary for the proper operation of the vehicle's transmission. The neutral position sensor is crucial as it informs the PCM when the transmission is in neutral, thus allowing the vehicle to start safely. This sensor is generally located in or near the transmission assembly. Any abnormal output from this sensor can lead to difficulties in shifting gears or starting the engine. Troubleshooting for this DTC requires careful inspection of several components, circuits, and the PCM itself to accurately pinpoint the source of the problem. The neutral position sensor is integral to the vehicle's operation, specifically concerning gear shifts and drivetrain management. Its primary role is to send signals to the Powertrain Control Module, PCM, regarding the position of the transmission, whether it is in neutral or otherwise. This sensor is typically located in close proximity to the transmission assembly, ensuring accurate readings of the current transmission state. When the PCM receives an output voltage exceeding specified thresholds, it interprets this as a defect, prompting the storage of DTC P086D. It is crucial for the PCM to receive accurate information from this sensor to avoid unintended operational issues. If the sensor generates a high voltage signal, it may indicate a fault in the sensor itself or issues within the circuit connected to it, necessitating a structured troubleshooting approach. The potential reasons for DTC P086D largely center around three main components: the neutral position sensor, the external wiring circuit, and the PCM itself. A faulty neutral position sensor is often the primary suspect, as it is responsible for relaying accurate information about the gear position to the PCM. A damaged external circuit can also create disruptions in the communication between components, leading to incorrectly high voltage readings. Lastly, if these components are functioning correctly, the issue may lie within the PCM, which could be reporting inaccurate data due to internal faults. Each of these possibilities must be considered during the diagnostic process to identify the true source of the high voltage output. When encountering DTC P086D, several symptoms may manifest that could alert the driver to underlying issues. Common symptoms include abnormal behavior during gear shifting, such as the inability to shift into or out of various gears smoothly. Additionally, the vehicle may face challenges in starting, as the PCM might misinterpret the transmission status due to faulty signals from the neutral position sensor. Drivers may also notice warning lights on the dashboard that indicate a transmission fault or service requirement. If these symptoms are observed, it's crucial to perform diagnostic checks to ascertain whether the root cause aligns with the identified DTC. Ignoring these indicators can lead to more significant drivetrain problems and safety concerns. The first step in troubleshooting DTC P086D involves preparing the vehicle for diagnostics. Begin by turning the vehicle to the on mode without starting the engine. This setting powers the vehicle's electrical system, allowing for active monitoring of diagnostic data through the Honda Diagnostic System, HDS. Once in the on position, check the HDS for the value reported by the neutral position sensor. For normal operation, this value should be around 0 volts, confirming that the sensor is functioning within expected parameters. If the value deviates significantly, it indicates an abnormality, prompting further inspection of either the sensor or associated wiring. This step is essential to establish a baseline of the sensor's performance before moving on to invasive diagnostics. In this step, continuing from the previous HDS readings, the focus shifts to the neutral position sensor itself. Ensure that the 4P connector of the neutral position sensor is disconnected to avoid erroneous readings. With the connector unplugged, perform a detailed inspection by switching the ignition to the on mode. At this point, you should measure the output voltage from the sensor terminals. According to specification, a normal output should register about 5.0 volts when tested in this condition. If this measurement is achieved, attention should be directed towards other components or circuits, as the sensor appears to be functioning correctly. However, if the voltage is outside this normal range, the sensor itself is likely at fault and should be replaced to remedy the DTC issue. Next, the troubleshooting process takes a closer look at the external circuits connected to the neutral position sensor. This requires preparing the assessment by ensuring that both the neutral position sensor 4P connector and the PCM connector E, 80P are disconnected. Following this step, inspect the wiring between the NSS1 and SG1 circuits to identify any potential open circuits or shorts. Specifically, with the ignition set to off for open wire inspections, a reading of less than 1 ohm indicates that the circuit is intact. For the instance of checking if NSS1 is shorted to power, switch the ignition back to on and confirm it is not shorted. This meticulous methodology in inspecting the wiring is fundamental to ensuring that the electrical signals are correctly transmitted without interruptions. The final step in addressing DTC P086D requires evaluating the Powertrain Control Module, PCM, itself. If earlier inspections of the neutral position sensor and wiring circuits yielded normal results, it leads to the determination that the PCM might be the source of the problem. The PCM is a critical electronic component that oversees numerous engine and transmission functions. If it is found to be malfunctioning or failing to process signals appropriately, it may need repair or replacement. Conducting tests through the HDS will ensure that any faults in PCM functionality are appropriately recorded and assessed. Understanding the PCM's role in managing data flow from the sensor is vital, as it ultimately governs the behavior of the vehicle regarding gear positions and other essential functions. After completing all necessary repairs or component replacements for DTC P086D, it is imperative to verify the success of the repairs made. This involves a thorough re-evaluation of the vehicle and rerunning the diagnostic tests to ensure that the DTC does not reappear. Utilize the HDS system to clear any previous codes stored in the PCM, and then perform a drive cycle, allowing the vehicle's systems to recalibrate. Monitor the HDS for feedback from the neutral position sensor, ensuring that it consistently outputs the expected parameters. If the readings are confirmed to be normal, you can then conclude that the repair was successful and the issue has been resolved correctly. To prevent encountering DTC P086D in the future, it is essential to engage in regular preventive maintenance practices concerning the neutral position sensor and its associated circuits. Scheduling routine inspections can help identify any wear or degradation in the sensor or wiring harnesses before they lead to failures. It is advisable to examine the condition of all connectors, ensuring that they are clean and free of corrosion, which can impede electrical flow. Additionally, keeping an eye on the vehicle's operational behavior and addressing any irregularities immediately can mitigate potential issues. Engaging a qualified technician for periodic reviews of the electrical system might also be wise, as they can identify hidden faults not evident in casual inspections. In summary, DTC P086D highlights essential aspects of transmission sensor functionality and the critical role the neutral position sensor plays in vehicle operation. The troubleshooting process involves structured inspections through various components and circuits to isolate the issue efficiently. By understanding the functions of the neutral position sensor and the PCM, repair technicians can swiftly pinpoint faults and implement effective repairs. Regular inspections and proper maintenance are paramount in reducing the likelihood of similar problems in the future. Ultimately, keeping the vehicle in good working condition not only safeguards its performance, but also ensures the driver's safety on the road. Please like and subscribe to the channel. See you next time.